welcome to Problems and Solutions. Today we'll solve problem 8 of chapter 4 of Physics for Scientists and Engineers. The figure shows a 20 kg block sliding on a 10 kg block. All surfaces are frictionless and the pulley is massless and frictionless. Find the acceleration of each block and the tension in the string that connects the block. Okay, let's start drawing the free body diagram of each block. So here we have a 20 kg block, inclined of course, so let's incline it. Here we have, and also the 10 kg block, also inclined. So here we have. Let's also draw our reference. So here we have our reference inclined 20 degrees as the surface, of course. Okay, so here we have our X and our Y direction. And let's identify the blocks as block 2 of 20 kilograms and 1 the block of 10 kilograms. Now let's draw the forces acting on these blocks. Here we have the tension in the string. Of course, the tension in the string is the same for both blocks because it's the same string. So here we have tension and the same tension. Tension and tension. Now let's look at the block of 20 kilograms. Here we have the weight of the block, that is m2 times g, and the reaction of the surface. Here, perpendicular to the surface, we have the reaction of the surface and 2 acting on block 2. Of course, the reaction in block acting on block 2 is the same as the force block 2 provokes on block 1, action and reaction. So here we have, let's draw it. Oh, okay. Here we have acting on block 1, the same force in the opposite direction. Action and reaction, of course. And also we have the reaction of this surface acting on block 1. So here, let's draw it here. N1. And also we have the weight of block 1, m1 times g. And these are the forces acting on both blocks. It's necessary also to represent the angles. So here we have here we will have the angle of 20 degrees. Let's represent as theta. And here also the same angle. Now it's only necessary to write the equations to solve the problem. So let's do it. We will sum the forces in the x direction. So we can write that the tension for block 2 minus m2g sine of theta. This equals the mass m2 times the acceleration of block 2. Now for the block 1, we'll have the tension minus m1 g sine of theta. We are projecting both weights in the x direction. This equals m1 a1, the acceleration of block 1, of course. Now we can subtract the first equation for the subtract one equation from the other. It's only a matter of choice which one we will subtract. So subtracting one equation from the other, we can write that m1 minus m2 g sine of theta equals m2 minus m2a2 minus m1a1. So what I did was to multiply the second equation by minus 1 and sum with the first equation. So we have this equation, and now we can use that the accelerations of both blocks are related to each other. As block 1 goes upward, block 2 goes downward at the same rate. So we can write that A2 equals minus A1. So this implies that we can copy this and substitute A2 by minus A1. So we have here minus m1 plus m2 a1. Therefore, the acceleration a1 will be minus, here, instead of minus, we can change the order here. It's better, it's more elegant. So we can write m2 minus m1 divided by m1 plus m2 multiplied by g sine of theta. And this is the acceleration 1. A1 equals, using our numerical values, 20 kilograms minus 10, so we have 10 kilograms divided by the sum, 20 plus 10, 30 kilograms, multiplied by 9.81, multiplied by sine of 20 degrees. Therefore, the acceleration of block 1 will be let's use our calculator. We'll have 10 times 9.81 times sine of 20 degrees divided by 30 kilograms. There is 1.12 meters per second. This is the item A. Of course, the acceleration of block 2 will be minus 1.12. It's not necessary to solve it. And item B is the tension. The tension is easy. We can take one of the equations. Let's take the second equation. And okay, here we have the tension equals, we can put M1 here, and we have G sine of theta plus A1. So the tension will be 10 kilograms multiplied by 9.81 sine of 20 degrees plus 1.12. Therefore, the tension will be, here we have 1.12 plus 9.81 times sine of 20 degrees times 10. Okay, 4.7 newtons is the tension in the string. And that's it. Here we have the problem is solved.